All right, guys, mistake number 2 is not showing your work. So if you're here, you should be following along with these slides. And there's the link on Canvas to that Pear Deck as we go through this. You don't have to take a lot of notes, but I do want you to follow along with the slides. And at the end, there's going to be a couple problems in that slide presentation that I want you to try solving with some of these techniques. So mistake number 2, not showing your work. Even though it's not required, on this test, no one is going to grade your work. All that's going to get graded is do you have the correct answer or not. But even though it's not required, it's still a great idea to show your work. All right, so we all know, and I'm going to read through a couple things here as we talk about this, but when you hear this in a math class, you have to show your work. You grunt, you groan, you get upset, everyone sighs, all right? And we all went through that with our math teachers when they tell you that you must show your work, right? We give you all sorts of reasons why it's important to show your work. You know, stuff like it shows me that you did the work and not just looked up the answer. That's a big one right now with so many programs like Photomath that just give you answers. How am I supposed to know what you did wrong if I can't see your brain? Teachers like to see your work so they can help you find where you made mistakes, right? People can't trust your answers if you can't show them how you got it. In the real world, that's probably the biggest one, all right? At some point, someone's going to say, how do you know that that's true, or prove it, and you need to be able to show them. These are all true. But here's the one I want you to focus on for this test, why you should show your work. You show your work so that you can see what your brain can't think. All right, what's going to happen, you're going to sit down to this 40 question test. You're going to have an hour and a half to take it. And that's a stressful situation to be in. So your mind's already occupied with worrying about this test. And on top of that, you're going to pile math and formulas and story problems on top of that worry, and it's going to make it even harder to keep things where they belong, to sort things out in your head. So write your work so that you can see your thoughts, all right? You need to be able to see what is going on in your head just to take some of the pressure off of your head, right? If you can see what you're doing on paper, it's less strain on your mind. You can focus on thinking through the problem instead of juggling the information it's giving you. And this doesn't have to be hard questions, right? I mean, if I asked you what x minus 2 squared is, most of you are going to need to do that on paper. That's a hard problem to do in your head. So a lot of you are going to need to show the steps and to put it on paper and show your work to get to the answer. But it helps to see your thoughts even on the easy problems, like -7 plus 5. You were trained for a very long time that 7 plus 5 is 12. So when you see 7, or when you hear 7 and a plus and a 5, your brain thinks 12 because that's what it was trained to do. 7 and 5 combine to be 12. But if you write that on paper, you can see the mistake in your thought. You can see that negative in front of the 7, and all of a sudden, -7 plus 5, that made sense in your head. It doesn't make sense when you look at it because you can see the negative sign and recognize, oh, I'm doing the math wrong. That's actually -2, all right? So show your work so that you can see what's going on in your head, all right, and catch those mistakes. You also follow the same thought pattern until something triggers a change, all right? Your head is going to keep thinking through the math problem in the same way, and it's going to keep following the same steps unless something triggers it to do something different. And a lot of times showing your work and writing things down can be the thing that triggers your brain that you're doing it wrong. I love this question. How many times do you multiply 3 by itself to get 81? Because it doesn't matter if I ask students or high school teachers or elementary teachers, Most people get this wrong. Their thinking is great thinking, but they answer it wrong. Because here's what you do in your head. Okay, 3 times 3 is 9. You can multiply by 3s. That's not too hard. Times 3 again is 27. Times 3 again is 81. So in your head, you had 4 3s. You might have even counted on your finger, right? 3 times 3, that's 9. I'm sorry, those don't look like fingers. Times 3 again, that's 27. Times 3 again, and again, these represent your fingers, right? Now I'm at 81. Oh, so the answer is 4 because I have 1, 2, 3, 4 3s, which is absolutely wrong. And it's hard to see that if you don't show that on paper or recognize that maybe you're thinking incorrectly. If all of a sudden you do the same math, but you do it on paper, in your head you said 3 times 3 was 9. Then you multiplied by 3 to get 27. Then you multiplied by 3 and got 81, which is what you wanted. But this gives your brain a chance to recognize its mistakes because there are 4 3s. But when I write it this way, I can see that I actually only multiplied 3 times, not 4 times. That's hard to see if you're stuck in a pattern in your head. So put it down on paper, get out of that kind of spiral thought pattern, all right? Before you type something in the calculator, write it on paper. Big one, you make a lot of mistakes on the calculator just because you type things in wrong. And the calculator doesn't tell you that. The calculator doesn't say, are you sure you want that 2 to be a negative? Don't you want to put that negative in parentheses before you square it? It doesn't tell you that your thinking is wrong, and you just trust that whatever it tells you is correct. If you write something on paper first, it might help trigger, first of all, what should go in the calculator. And then once you type it in the calculator, you have something to look at and compare it to. So 2 quick questions here. If A and B are independent, use the given information to find probability of B. You've learned that probability of A and B means multiply them together. So in my calculator, I'm going to put 0.5 times 0.4. You're not even going to write it down. You're just going to put it in the calculator. If you take the time to write it on paper first, you know that the formula says probability of A and B equals probability of A times the probability of B. So 0.4 goes on this side, 0.5 goes right here. There's an equal sign in between. Oh, I wasn't supposed to multiply on my calculator. I was supposed to divide on my calculator. We practiced this a lot with the quadratic formula. We practiced making sure that you plugged in numbers and wrote them the right way first so that when you plugged them in, your calculator gave you an answer and you could trust that the answer was correct. All right. So write it first, then go ahead and put it in the calculator, but make sure you have something written, especially if it's a big, ugly formula. Make sure you have something written first that you can compare it to make sure you do it correctly. All right. Next thing. I love, you guys giggle when I say this in the classroom, but connect your muscle memory to your memory, all right? I know that's probably not a thing, but in math class, it can be. You've done a lot of math on paper, and in the process, you've created a lot of muscle memory that you don't even realize when it comes to solving math. Clear back in elementary school when you were having to do addition and division and follow all those patterns, you were creating memory, muscle memory in doing those patterns. This test is on a computer screen. You're going to see this on a computer screen, and at first you might be confused what you're supposed to do. 9 times 2 is 18, so 3 times 2 means, x equals 6. Or you might just type in your calculator. Let's see, you multiply across the top, then you divide by 9, put it in your calculator, get the correct answer, move on. Which is wrong, by the way. Don't get the correct answer that way. But as soon as you write this same problem on a piece of paper in front of you, all of a sudden, those months of solving these kinds of problems in elementary school, or I guess it wouldn't have been elementary in Utah, you would have been in intermediate school. The minute you write that on paper, the next thing that your muscle memory tells you to do is this. And that's a universal step, no matter where you grew up, no matter what school you went to. But if you're just looking at it on a computer screen, you don't have that muscle memory, and it's harder to remember how to solve the problem. So write the problem on the paper. Let that muscle memory trigger what you're supposed to do to solve the problem. All right? Okay, next one. You're less likely, and this will be the last one before you try a couple of these. You're less likely to skip steps if you see them. This question I actually did wrong the first time because I did exactly what it said not to do. Hey, I'm the math teacher. I don't need to write down my work. But you do. Because when you do it in your head, you skip steps, and even if you're a math teacher, you make mistakes. So it says, Tabitha is answering 4 multiple choice questions. Each question, there's 3 possible answers, only one of which is correct. If Tabitha randomly answers each question, what's the probability she gets them correctly? So in my head, I'm going to write it so you can see my thought. I said, oh, there's only one right answer, so 1 out of 4 times 1 out of 4 times 1 out of 4 times 1 out of 4 equals 1 out of 256. Great. Then I looked over here and realized, oh, I'm supposed to have an 81 on the bottom. Luckily, this test question didn't give me the common mistake answers. It gave me 81 on the bottom of all of these. So it told me I did something wrong. So when I went back and looked at the question and showed my steps instead, I know that probability means multiply things together. We all know that. But it wants me to take the probability of getting a correct answer. Well, the probability of getting a correct answer when I read the problem, there's only one correct answer. Well, duh. Out of 3 possible answers. Now that I've written that first step, what the probability is, I can recognize quickly I should have done 1/3, 1/3, 1/3, and 1/3, not fourths. Show your steps, even the easy ones, so that you can see them, so that you can help catch those mistakes and not make those mistakes, all right? Okay, now I want you to try this. There's 4 practice problems down here. I want you to do each problem, and I want you to be dramatic with how many steps you show, okay? If it goes through your brain, I want you to write it on paper. Anything that comes up, and I want you to show as much work, go out of your way to be dramatic and show more steps than maybe any sane person would do. But I want you to practice this. I want you to practice showing your work, showing every little step, which you're probably not going to do on the test. You're probably not going to show every little step, but we're going to practice showing these steps to try to help you get in a pattern and catch some of the mistakes you might have made if you're not showing your work. All right, so 4 problems, give them a try. I want you to take a picture of the 4 of them when you're done, and I want you to submit that on Canvas under the Show Your Work assignment.